Hello students, so we will discuss two-terminal quantum dot devices. In these devices we calculate current as a function of voltage. And after that we add a third terminal is called the gate. And this gate is used to independently control the potential of the conductor. So with this we actually create the transistor building block. The transistor is the building block of modern electronics. Now we take the simplest case of quantum dot between two contacts. Like suppose this is a contact and this is a contact, and in between we place a molecule. So this is a contact, this is also a contact, there is a molecule in between. Now we all know that quantum dot is a zero-dimensional conductor, and so by zero-dimension means the electrons are confined in all directions. So a single molecule isolated in space. Isolated in space is a good example of quantum dot. Now, so we are using square wells on both sides. Square wells which are confining the quantum dot. Now when this sort of quantum confinement takes place, so it is characterized by something called the energies. They become discrete. That means we will now have a different energy level instead of a continuous energy. So let's write once again energy equals discrete. and the energy levels, they are measured with respect to a vacuum level. And in fact, vacuum energy, not level. This vacuum energy is defined as a potential energy of a free electron in vacuum. Now, if electric field is present, the vacuum energy will vary with position. In this conditions, what we do next? We add electrons to the molecule, and to each energy level, and each energy level it takes 2 electrons, one of each spin. 2 electrons, one is of upspin and downspin, and the highest occupied energy level molecular orbital is called Homo. Highest occupied molecular orbital, and the lowest unoccupied molecular orbital is called Lumo. So highest occupied molecular orbital, lowest unoccupied molecular orbital. And the most chemically stable material, this Homo is completely filled. Whereas if they are partly filled, they will add to the reactivity. Okay. So for the stable molecules are completely filled. If they are unstable, that means it is partially filled, and then they are open for reactions. Now, earlier it was stated that charge transfer can take place only in partly filled states. And this is best achieved by if we add electrons to the node, or if we subtract electrons from Homo. Both of them will lead to partly filled states, and it will enhance the reactivity of the molecule. And modifying this electron population in other states requires much more energy. So these two conditions, it requires much more energy. So we will ignore, that is why what we'll do, we will ignore. ঠিক আছে, আমাকে একটা গ্রিন টি দিয়ে দেবেন, লেমন, হ্যাঁ, ignore all denote all molecular orbitals except Homo and Lumo. Okay, now next, what is to be defined is what do we mean by an ionization potential and electron affinity. These two are very important terms that needs to be defined. Now, the ionization potential of a molecule is actually the binding energy of an electron in the hole. And this is what we know as the ionization potential. On the other hand, if we say about electron affinity is the binding energy of electrons in the loop. That means we have an energy molecule levels like this. So let's say these are the energy levels, say, and say this is the vacuum energy, and these are the molecular orbitals. This is the vacuum energy. And these are the energy levels, and these are the molecular orbitals. So corresponding to that, we can have an energy level like this. Say these are the energy levels in the vacuum energy, and we have electrons with opposite spin and levels. So this is your Homo, and just above that is your Lumo, and in between them is your Fermi energy. So from this is your ionization potential from Homo to your, sorry, not this one. This is your ionization potential, and this is from Lumo. From Lumo to this energy is your electron affinity. So this figure is actually a square well approximation of a molecule.